and hand over to Andrew, and yeah, just hopefully all on mute. We'll have questions at the end, so just put anything in the chat, but you can do that as we're going along if you like, if you think of a question, and then we'll just go through them all at the end. Okay, over to you, Andrew. Thank you.
Thanks, Jeb. Hi, everyone. I think this is going to be the most casual presentation you might have, but I'm going to blitz through a bunch of stuff. It's going to be put it across in a sort of a grand scheme and the grand scheme of things. But what I'd like you to do is think about it as from your own personal household point of view, because success in the agenda that I'll cover here is down to pretty much every single household and every single business maybe doing something different or better in the future. So I will share a screen and I'll get cracking. So my role is water efficiency manager. I look after demand reduction strategy, and I have quite possibly the most perverse or the strangest role in any industry around. I suppose I've got, we have a monopoly, so everyone in our area, which is here. So this is our patch. So the dark blue areas are where we supply water. The light blue shaded area is where we also take wastewater. So you're roughly looking at 10 million people get our clean water every day, and we take wastewater, our sewage, from about 15 million people, and we have a lot of pipes. It's a huge, complex system. A lot of it's very, very old, but it does provide fantastic quality drinking water. The drinking quality water here is brilliant. It's world class. I work internationally, and this is top of the bill, really. But my role is the strangest role, as I was saying before. So 100% of the people living in our area use our product. Pretty much 100% of everyone using that product every day. But my role is to get 100% of our entire customer base to use less of our product. So not many industries really fall into that category. And I'll show you why in a sec. So we're based in Reading. You've probably seen that big round building right next to the bridge, right on the Thames. And on the map there, the yellow dot are you guys, roughly, without being too focused on northings and eastings or GPS coordinates. That's pretty much where you are in the grand scheme of things. So we've got a number of water resource zones. So we have the area in London. We don't cover all of London. There are 4 water companies that supply London, and we've got the water resource zones outside of London. And you all fall into this what we call the Swindon Oxford, SWOX. We abbreviate everything. There's too many abbreviations, but we certainly add to that problem. But it's a very, very complex system. And most of the water, if you look at the whole area we supply, most of the water that we supply across the population comes from the River Thames. But in SWOX, it's a mixture of river water and groundwater, so aquifer. And depending on which of those shaded council areas or also our smaller water resource zones you're in, depends on what mix of water and where it comes from. But a lot of the time, it'll be, for you guys, it'll be groundwater. Our challenge is this. We simply don't have enough water in the future in a dry year scenario because of the growing population. Kind of sounds a bit weird. I'm from a different land, and I would never expect coming here going, oh, it's going to be dry and there's not enough water. I would have thought it'd be the opposite way around. But quick quiz here, and it's too bad we're not in the pub. Maybe some of you still are, but if we were in the pub, my pub quiz question would be, which Australian state capital city gets more rain than London or the southeast of England? It's a terrible trick question. The truth is they all do. So this part of the world does not actually get a lot on average rainfall. I know averages sometimes come with barbs and double-edged sword. You can misread them. But on average, we actually don't get a lot of water. So the trouble is there's lots and lots of people taken from the system every single day. And a lot of the time we don't get enough going back into that system. So when you plug those bad scenarios into the model and you play out to the end of the century, because our assets, we need to think and plan to the end of the century. The stuff that we build, treatment plants, pipes, reservoirs, they'll be here way past that time. But when you look at that far ahead, the growing population, we don't have enough. So there's a big gap between what we have to supply, what's in demand by the population, and what we're able to take from the environment. And we have to close that gap. And we do that by installing meters, doing water efficiency, fixing leaks to bring that demand down. And we need to bring more water into our system. So, the Southeast, Thames Valley included, is growing tremendously quick. New homes, you drive around, you see the estates, new homes being built, people moving to the area. What that basically is, more mouths to feed. That's our problem, though. When we want to talk about water efficiency and being, the idea of saving water and, saving every drop, it's a difficult audience to sort of get that message to, because you often think of just grey, dry, grey, drizzly, wet weather. There's loads and loads of water. It falls from the sky. It's free resource. It's actually anything but that. So we get a lot of grey days, but in the total amount of rainfall, we don't get huge amounts. So and a lot of the time when it comes down, you can't capture it. So our systems here are old. Every square inch of land has been used for 500 plus years. And there's not a lot of valleys to dam. So it's all quite flat. So holding more water is quite difficult. So our water system is quite hand to mouth. It's, take it from the environment, treat it, store it, pump it, use it, go. And then if we can't take it from the environment, we run short quite quickly because of the sheer number of people taking from the system every day. So we're doing loads of stuff. And here's a snapshot of the water efficiency things we'll do. We go into homes, we go into businesses, we work with housing authorities, we have incentives. We've got an online calculator tool, which I think a link has been shared to you in the past. If it hasn't, we'll talk about it a little later on. But the big thing we do is we try and increase awareness about behavior change and what you can do at home, get people to understand how much water are they actually using in a house or in their place of work. Fix the losses. So network the water, like leakage on our own pipes, but leakage or what we call wastage inside people's homes, which I'll cover in a second as well. But there's a lot of different activities going on, but it's all being underpinned at the moment. The big one is this. We're rolling out smart meters, smart water meters. And when I say smart, it's the same thing. It captures the same data on how much you use. We just get the information more regularly. So it comes through a network, so we call it smart. So we're rolling out in London at the moment. It's not in your patch just yet, but I will have a slide to hopefully sow the seeds on when this might happen. But right now, this is what we are doing. And this little animation shows us in the last 5 years of installing smart meters across London, north and south the river, east to west. The blue, the big spikes in blue are where we're rolling out. It's a compulsory program. So a lot of the companies in the southeast are rolling out compulsory meter programs. It's approved by the government. And we're one of the only places in the world where we don't have full meter penetration. Everywhere else, North America, Asia, Australia, chunks of Africa, Middle East, Europe, compulsory metering. So we are kind of playing catch up to that meter penetration amount. The good news is that the kit that we're putting in the ground is great technology. So we're kind of playing catch up to the number of meters, but we'll leapfrog everyone when it comes to what we do with that data and convert it into a savings. So there's lots of things going on there. We take the data, we put it into what we call dashboards. Lots of analytics, lots of data scientists, data visualizers to understand where water is going, where it's not going, how it's being used, and what we should do and focus on to be most effective in saving this precious resource. It's very difficult. Metering is brilliant. I mean, it's a core piece of kit. It's like a pumping station. It's like a pipe. You need a meter. It's very difficult to make something better or fix it if you're not measuring it. Metering, that's all it does. It just measures stuff. We've got over 500,000 smart meters in London. That number is going to go north pretty soon. We're installing over the next 4 and a bit years another 690,000 meters. Most of those will be in London at the moment. It's a complete game changer with understanding water in general. And what we are finding is that a lot of homes, around about 13%, never stop flowing. So it's a leak, which I'll show you in a second why. The customers who are on a smart meter to date, they can go on their account, jump on the Thames Water website, log into their account, and they can see their usage. They can see it in a number of different ways, and we're going to improve this capability over time. We're going to use this data to email people and text people automatically if something is going on, and we'll also identify them immediately if we think there's a leak in their house. So it's a really great thing for home insurance. It's a great thing for saving water, because a lot of the time those leaks, those little trickles and dripping taps and toilets and things can go on for months or a year before you really know about it. But that's actually water being used and lost. And that's water we've taken from the local environment, treated it to high standard, pumped it to you at high energy cost, and then it's being lost that way. So every little drop that we can save on our network and in people's homes and businesses makes a huge difference, particularly when we've got about 4 million homes to feed every day. So what we're hoping to do is fast track smart meter installations throughout the Thames Valley, including Watlington area. It's not approved yet, but we're hoping to bring it forward in a response to the government's call for green economic recovery. And that's in response to the economic impact the country's had from COVID. So the government's gone out there and said to big utility and to major cities, can you bring forward infrastructure? Can you employ people? Can you do things to fast track and get the economy going and employ people, get them back into work? And yes, we can. So we've put forward a proposal. It's to bring forward smart meter installations. Now, we would have had this on the plan from 2025 onwards, but we're hoping to bring it forward. Over the next month or so, we'll get a yes or no on that. But if we can, it just means it's a really, really good thing because we're able to then find the leaks in your areas, and it gives people more visibility of their actual water consumption so they can control their water use better. COVID, completely rewritten water use in homes and businesses. Not rocket science stuff, but for the simple reason is that our ways of working have changed. I'm working from home. Many people in this call might be still working from home. So, what we're doing, instead of using water in an office place or a place of work, we're using the water during the day at home. So during the early times of COVID, and a lot of times right now, it's almost like having 7 weekend days of water consumption. That's the early spike. So first lockdown last year, the black line is 2020, the big COVID year last year. The blue line is 2019, and we would consider that a pretty normal usage year. You'll get peaks and troughs depending on holidays, weather. As soon as it gets hot and dry, water use goes up. But in COVID, what we saw in 2020 is everyone was at home, particularly in that first early summertime, and it amplified the peak. We've never had demand for water so high. It was the highest we've ever seen. Quite keen not to experience that again, to be honest with you, but that's how we have to do it. So as COVID goes through, we saw further peaks, but overall, we saw a year where the average consumption, irrespective of the weather, was higher. And it's just the simple reason that people are at home. This is a London graph, and I'll show you the Thames Valley graph equivalent in a second. This is all the different lines here represent a different house type. A detached house, a semi-detached house, a flat, a terrace house, because they're all quite different. There's lockdown, big spikes in water consumption, and this is broken down into almost like an average per person type of metric, but it's the same principle, same trend for our whole house. So you have this massive spike when everyone's at home using water. But even after lockdowns ended and we went into various different phases of lockdown and then some returning to work, what we've seen now is a consistently higher amount of water being used in homes and a consistently lower amount being used in businesses. Not all business categories, but just some. Agriculture hasn't really been affected. Things like hospitality and offices absolutely have. Leisure facilities, of course, because they've been closed. And we saw every lockdown that's happened, we've seen a spike in consumption. So it makes perfect sense. We're at home more, that's where we're using the water. The next graph, this is Thames Valley, broken down across different years. So the line to focus on there is the green year. That's the last year's COVID year. Oops, sorry, hang on, I've missed a bit. I'll go back. So over here is your big spike in COVID. And then what you've seen throughout the entire year is a higher consumption level in homes of water than any other year we've seen, irrespective of the weather. Thames Valley, in your area in particular, will have a higher proportion of this change compared to London. And it's because of a lot of people that were commuting into London are now just full-time at home in your area. So it makes perfect sense. These numbers are not completely final, but the trends are pretty much there, and we'll monitor them as we monitor them many times a day to work out exactly what's going on. When you do break it down across your area into different types of homes, you'll see that there's a big spike that represents the first lockdown, but you'll see the different patterns in consumption and different spikes based on the different housing type. The thing to highlight here is where you've got a semi-detached house and a detached house, you'll have a higher water use, but also higher spikes. And for the simple reason is that typically those households have a slightly higher occupancy, more people, more adults at home, but you've got gardens compared to flats. So it's the additional chunk of water use that's happening outside the house, in a garden, on a lawn, sprinklers, maybe different fun activities of, paddling pools and so forth in hot days. But that's the pattern that we're seeing. This is the same pattern we're seeing across the entire country. No difference, except that we'll have hotter days and you'll see those spikes higher. Since COVID, all the way through, we've had a sustained increase in household consumption in your patch. Right. This is in like this one on the y-axis on the left-hand side is basically the average amount of water that a house, which is the dark blue chunks, and the average amount of water use per day that we'd see through a business, which is the light blue, all the way through a normal year, which is here, and you get that typical seasonal up and down. In summertime, the water consumption goes up. In wintertime, the water consumption goes down. We're either not showering as much, we're not using water in the back garden at all, and during wintertime. So you get that peaks and troughs. Then we had lockdown. The household consumption, you see the bottom, increases, but it's marginal because you've got a different scale on this graph here. The big shift is the dramatic drop in business water use. You saw it in London, we saw it in every region of the country. So, and it's just because we had businesses that were either not operating, on reduced operating, or sadly went out of business. And that consumption across the entire business sector dramatically fell. So you've actually got areas that we used less water in total last year, but their household consumption increased. This graph here is very simple to explain. It's the percentage increase in water use in homes across every water company in England, Wales, and Scotland. So over the last 12 months, you've seen an average increase in household usage ranging between 4 and 19%. So it's a fairly big chunk of additional water use that's being used in homes, but it's almost mostly offsetting the water use that was previously used in business sites during the course of a weekday. But it does mean that we need to look at billing differently, support tariffs differently, information about how customers can save water. And, this is the same thing that all the energy sector is looking at right now. You've had an impact from travel. So there's all these different movements are going, all these different sectors are where we had traditionally been operating as a daily routine. But what we're seeing there in water use, we need to take this information and incorporate that into our future water resource planning. Do we need to think differently about what we do in the future? How much more important is metering and understanding where this is going? Do we do things differently on leakage? What are the support services for customers do we have to introduce? So at the moment, we are, and everyone else, all the water providers are understanding a new way of working. If you've heard the term per capita consumption, it means basically the average amount of water that a country or a supply area would be when you divide it by your population. It's usually misquoted and misinterpreted. It's not the average amount of water that the person uses, or maybe I'll say it's not the amount of water that an average person uses at all. So with smart metering and more data coming in regularly through the day, we now understand this a bit better. So we would report in the Thames water area, our PCC, our per capita consumption, as about 146 litres per person per day. That's the amount of water that goes into homes divided by what we think the population is. And no one has the perfect exact occupancy and population. You just have to make a guess. A good guess, very accurate guess, but we'll have a guess. But when you divide those two, you get 146 odd. That's gone up because of COVID. We now know it's a lot higher than that. But when you actually look at what people do use, the most common amount of water used in a day is about 100. So this is your shower, your bath, your taps, your basin, your kitchen, your other cleaning, dishwasher, washing machine, kettle, other bits and pieces around the house. When you add it up, it's about 100 litres per person per day. But what we found, a smaller number of households across the entire area use a lot more on average, and it skews the average. massively skews the average. Now, these are homes that are either leaking a lot, wasting a lot, or just using a lot for various different reasons. So we're now starting a very detailed piece of work to understand for those homes that use 5,000, 10,000, 20, 50,000 litres a house a day, why? And if we know why, then we can try and do something about it. So we're using this data like crazy at the moment. We are, from our smart metering in London, we're getting over 12 million meter reads a day. It's phenomenal volumes of data coming in. We're going to see that when we get into Thames Valley with smart metering as well. But in Thames Valley, we're taking the data that's on existing meter sites and all the sensors we've got across our network. That comes in and we're making lots of dashboards, a lot of analytics behind the scene to understand what we should be doing differently and better. So it's on average usage, where the leakage is, what's our water efficiency benefit? You know, are we doing the right thing? Can we use that information coupled with the weather forecast to do something proactively with our customer base instead of waiting for things to go wrong, which is exactly what we're doing. So we've got a green, amber, red system linked to the Met Office and our smart meter data, and we're able to forecast a fair way in advance when we think there might be an issue in a certain water resource zone, a town, a village, and we're stepping up different mechanisms, different levels of engagement, just from basic education all the way through to SMS text saying there might be a problem tonight. Can you pull back your water consumption? Thank you very much, and we'll let you know how we go in the morning. Right from really, really easy, great, everything's fine, to emergency, can we come to your area and help? We're using the smart meter data to try and do that more proactively, so we offset the risk of impacts to customers. The other thing we're doing is, I mentioned before that about 13% of the homes we've got smart meters in are showing that they're continuously flowing, just like leaks all the time. We are now reaching out to all those customers we're seeing that with letters and emails, and it's so successful that within about 7 or 10 days of the household getting an email, a letter from us saying, we think you've got a leak. It might be this is what you can do about it, and these are your options to fix it, and we can help. Within about 7 to 10 days, about 80% of all those leaks are fixed. So this is the power of data immediately, as opposed to waiting for an annual bill when the problem's already happened for 12 months and the bill's really high and you get a complaint. This is kind of like heading the whole thing off at the pass. And this is what it looks like on a super duper dashboard that we've got thousands of at the moment. This is just one property. This is one household. And all those bars on the right-hand side are pretty much leaks, just leaks, and that's the amount of water. Roughly over 2,000 litres a day, this one. It was one toilet. And if we fixed it, straight away, comes down to near zero. And we can quantify and see the immediate benefit that these interventions have for either a business or a household. Huge, huge difference, and it's a complete game changer on how we manage water going forward. So on the individual water efficiency things that we're doing, I covered this sort of palette, this suite of different interventions, but I'll focus on these ones here because I think they're probably a bit more relevant. Okay, we have a team called a Smarter Home Visit team. They're mostly in London at the moment, but when we start doing smart metering in the Thames Valley and your area, we will also step up that team there as well. They're a team of fantastic, wonderful people that just go around almost door to door, helping fix the leaks for free, installing water-saving devices for free, and giving you a personalized water plan. We're not in your area yet, but we will. I'm kind of like jumping in advance here, hopefully. But we used to offer it to everyone we had a smart meter installed, and we saved on average, about 35 litres per house per day. We're now using the data to focus this activity on the households that use over a certain amount, kind of a threshold of about 500 litres a day, and also the households that might have a leak. We've now, by doing that, we've actually doubled the savings per visit. So we're getting better bang for buck. And I think it's a much better way of targeting a solution for homes and businesses going forward. We also have a business visit team. We have 20 qualified plumbers working for me at the moment, going to various businesses, schools, sporting stadiums, leisure centres, care homes, hospitals, offices, restaurants, working in Thames Valley and in London. And they are going in there, doing the basics, and they are fixing stuff, fixing lots of stuff. And the best two things that you can do in any business across the country, based on our evidence now, is fix your leaking toilet, and in the men's bathroom, install sensors on the men's urinal. Those two things there are the most cost-effective water savers that we've got in the books for businesses. Dramatic savings. On the top right-hand side, we're also working with golf courses and the sporting leisure sector to understand and try and help them reduce the amount of water they use on irrigation. We're calling it discretionary water use, but it's basically irrigation on fields and sporting venues. You know, the simple thing is, why on earth are we taking world-class drinking quality water and sticking it back on grass? Can we find an alternative? This is a big issue right now. 30 degrees this week, pretty much every day. I can guarantee you that golf courses are irrigating like crazy, sporting fields are irrigating like crazy. Can we find alternative sources of water instead of taking this from potable sources, drinking quality sources? And we're doing that as much as we can. It's a long burn project, but it's an important one. So if you guys are members of sporting clubs, golf courses, please be a voice on water efficiency if you can. Watering in the middle of the day, in the middle of high sun and wind, is utterly pointless. You'll get about 10 to 5% of that water to the root zone. Pointless exercise, but they do it every day. And we're also working with every water company, every retailer, and all the regulators to try and find a better way that water efficiency can be delivered in every business across the country. So we are an extremely loud voice on that one there too. And that voice probably typically comes with my dodgy accent at the moment. We've got an app. We have an app that our staff use when they go into homes, and it's incredibly successful. And the reason why I'm pointing out here is that we've also embedded a thing called priority services. So if you're a customer that might have some vulnerability circumstances over a certain age, you've got some medical concerns, pregnant, little kids at home, all these different categories, hearing impaired, sight loss, mobility issues, just back from hospital, whole range of categories, you are eligible to be listed on our priority services. That essentially means that if you've got an issue, or if we have an issue in your area, we'll come to you first. So if you think you're eligible, please just just Google Thames Water priority services, have a look if you're eligible. If you're eligible, please register. It is the right thing to do. It's the same with the electricity companies, the gas companies, and the phone and the fire brigade. They all have priority services registers, and we're trying to link them all up together. But we've embedded priority service registration in with our water efficiency assistance for customers. If you're going to go to someone's house, do 5 things instead of one thing is kind of the principle there. We've also teamed up with Green Redeem. So in the areas that we are rolling out smart meters, we're working with Green Redeem, who incentivize people to save more by giving them points. It's kind of like reward points, like Sainsbury's have Nectar points. We're working with Green Redeem. So the customers that are getting smart meters in there with that lots and lots of data to understand their consumption, when they're saving more water, they get more points, and they can use those points for prize draws, shopping discounts or gift vouchers, or even donate them to charity. Very, very successful. We just need to get more bums on seats. Early days, lots to learn, but it's quite exciting. And I think we're doing the right thing. I'll skip that one there because that's quite detailed. Right, here we go. I'll take hands up, and if everyone wants to come off mute, I'll go off piste here. But if you want to come off mute and have a go, here's the quiz question. How many liters of water does this little trickle here in this leaky loo add up to in one day?
100.
All right, I'll play it again. That little dribble. How many liters in a day? I've heard one answer was 100. I'll take
200.
200. Any
150.
more? How much, sorry?
150.
150.
Oh, hedging the bets.
18,000.
Definitely not that.
Well, I'm looking at the dribble. That's about a litre a minute, I'd say.
So
Lot.
500.
that particular leaky loo is 600.
Oh, I was closest.
So that little leaky loo, 1 in 20 homes has a leaky loo. They're pretty much all push-button dual flush toilets.
Yeah.
If you've got a leaky loo, the average leaky loo ranges between 250 and 400 litres a day, somewhere in there, so a little less than that. We fix loos every day in homes and businesses that exceed 8,000 litres a day. If you've got a leaky loo, please, please, please fix it, because the average one, even a small one, is likely to double your entire water bill if you meet it. So lots to do there. This is what we've been doing. We've been working with the manufacturing sector, the bathroom manufacturers, toilet manufacturers, government regulators. We now have, because of our home and business visit teams and our smart meter data, we have the UK and possibly the world's largest data set on leaky loos. We know what's going wrong, what brand, what design, what material, why, what age, the whole lot. I mean, it's very sexy stuff. So we are working with the industry to try and engineer this problem out of existence, because the amount of water loss here is enough to supply several cities when you add it up across the nation. It's crazy. I won't go into the stats there for you to have a look at, but needless to say, it's either going to be a valve in your drop valve or the rubber seal at the bottom, it fails, or the inlet valve, which also has a rubber seal typically, or it can be neoprene or silicone. But there's some fundamental design flaws because there's no safety factor. If there's a little issue there, it just lets water out. And it's dribbling into the bowl of the toilet. It's not dribbling outside unless you've got an old overflow siphon, and it's not dribbling on the floor of the toilet. It's just dribbling into the bowl. So push button dual flush toilets, have a look. If you've got a leaky loo, fix it, because at the moment it's probably costing you a lot, and it's a lot of water we're taking from the environment to source that. And we're getting a lot of attention. So we've been on BBC Radio, Costing the Earth show, lots of different things. That's Tom from Costing the Earth and Countryfile. He and I are in regular contact because I'm just feeding him stats and information for his next show pretty much. But yeah, big topic, and we need everyone's help to engineer this out of existence. We work with Waterwise in this. The document on the left-hand side is a joint statement with all the companies and the manufacturers saying, we acknowledge there's a problem out there, we want to fix it. On the right-hand side is a piece of consumer guidance that Waterwise did with us, with all the companies, to say, these are the things to look out for, and to avoid leaky loo, this is what we'd suggest you go buy or try and avoid. So it's really, really simple language, very, very simple. It's there for homeowners, businesses, developers, everyone. It's just a one-pager. And you can Google them, Waterwise, leaky loos, and you'll find those. We do a lot of campaigns. We do a lot of outreach to customers. On social media, we do things relative to each individual area. It's expensive to do that, and sometimes it's difficult to measure how successful it is. But what we need to do is an always on, just keep that drum beat going and stick water efficiency, water resources on the agenda. Because most people in the country, let alone just our local patch, but most people in the country don't think about water too often. In fact, when you ask them to jump on and do a water calculator or ask them about what they use in the house, it's probably the first time in their entire life they've had to think about it. So we've done things in the Daily Mail, Mail Online, print media, editorial articles, just to plant these seeds all the time, get other people to talk about it as opposed to just us. In fact, it's better that other people talk about it instead of just us as well. The more voices, the better. Lots of social media, lots of really odd, strange social media. It's not on here, but one of the social media was even the builder doing our house extension here. I saw him at the pub and I recorded a video of him talking about what he did as a kid in saving water that his parents taught him. It went viral on LinkedIn. He got thousands and thousands of hits. So every little helps on this one here, but we need to get this, you need to spread the word and just slowly tell people that this is actually an issue and there's a lot of things that they can do at home and business to save water. And we've got some new videos out there we're putting on Facebook, Instagram, Twitter, LinkedIn, and Google, various other ads and so forth, just about the very, very basics that you can do in the bathroom on dual flush buttons and leaky loos, because most people don't know which button to push on the dual flush. If I show you guys now the top 5 button designs, statistically, none of you would get all 5 right. I don't have them ready here to hand because it was only a short talk, but we've also got a video on short showers, kitchen taps, which is basically just don't leave it running, just turn the thing off when you're not needing it. and also the basics to do in the garden. They're short, sort of 10, 15-second videos. Right, I think everyone's been sent a link to the calculator. If you haven't, that's fine. If you haven't had a go, fine too. After this, tomorrow, next week, whenever, stick in your diary, just Google, search engine, Thames water calculator, have a go. And it'll quantify based on what you input in there, how much water we think that, or you think that you might be using, broken down into every room in the house, every device in the house. It'll show you how much water and how much cost and energy cost that also is, because of the hot water component. Your water consumption at home is the second biggest chunk of your energy bill. Does everyone know that one? Or your hot water usage? So your biggest chunk of your gas and electricity bill combined is keeping your house warm. The second biggest chunk of your combined gas and electricity bill is your hot water use. So saving water also reduces your energy bill. Reduces ours too, but yours is more important. Have a go at the calculator. It's just some basic questions. You'll be through it in minutes, and you can download your own personalized household water report showing you what you're using, where it is, and it'll give you the quick tips and wins on what you could be doing based on your personalized. It's a tailored audit really, but you can download your own PDF. Okay, last one. Lots of things happening now on a higher policy level. I won't go through the list here, but there are two things to focus on. DEFRA, which is the Department of Energy, Food and Rural Affairs, will soon, and I use soon caveated with lots of grey area aside, be launching an environment bill, and inside that we'll have a national water target. So this will put water efficiency on a level playing field with sort of energy efficiency, CO2 reduction. We don't have that for water yet. We need that for water. We need to put water efficiency, water saving on a higher platform. The other thing that they've committed to do is introduce a mandatory water label. So where you're buying all your energy using devices, your boiler, your TV, your microwave, your laptop has an A to G energy label on it. There's no equivalent for water. That will happen in a few years' time. You'll start seeing that in the DIY stores, and everything you buy online will have to display a label showing you how the water performance of that device. So that encourages better performance. Consumers want to buy the better products. Manufacturers don't want to be the G when their competitors are A and B. So that'll make things better over time. So all good things to come, I think, on this particular agenda. The water savings from that mandatory label in 30 or 40 years' time will be the biggest water savers in the country. It'll be the only thing that makes every house and every business more efficient. And that's it from me. I'll probably just open up to criticism, questions, lots of other things.
Brilliant. Thank you, Andrew. Thank you. That was absolutely fascinating. I've made loads of notes actually. Yeah, I know a few years ago, I actually did have somebody round from Thames Water who they were doing a sort of campaign. I think it was a few years ago. So I did have someone come round and
did you?
Yeah, I did. And he fitted, yeah, he sort of gave me the choice to, what sort of devices I wanted fitted. And in the end, we went for something on the upstairs bathroom tap.
Okay, you put an aerator on it. So that person was working for me.
Yeah, so it was brilliant. And at first the kids did complain, so they did notice the difference. But I'd say within days, no complaints. You just get used to it, and nobody notices now. Wouldn't even think twice about it.
The biggest saver you can do on any taps is just not leaving it run when you're not filling something or washing something.
Yeah, definitely.
Yeah, between 6 and 12 plus liters a minute. If you leave that go for a minute, you look at it and go, I've just lost 12-litre bottles of water. Why would I do that?
Right. We need some questions, everyone. Yeah, can everyone that has a question either, you don't, I mean, yeah, you could actually, if you don't want to write it, just, go for it. Anne. Do you want...
So thanks, Andrew. That was very interesting, an awful lot of information packed into quite a short period of time. I've got several questions, but I'll just start with the one that came up quite early on in your presentation. You showed a graph with the increase in population, I think it was till the end of this century, right? Which was quite dramatic. And I was just wondering where you got your figures from, whether it's related to developments and, for instance, include the Oxford-Cambridge Arc.
It does. Yeah, it does include Oxcam Arc. The figures are a mix of different sources, Office for National Statistics, all the government-led sources, and there's a few other sources such as Experian, Edge, Mosaic. So it's a real mix of data sources for population growth. Local authorities, every local authority data goes into that mix. We need it to be as accurate and widespread as we possibly can, because we use population statistics and data forecasts to map out our future water resource management planning. So our demand forecasting. So we need to understand, based on how many people are going to be in our area, either living or commuting every single day, to then how much water do we need to supply? So does it affect infrastructure, current infrastructure? Do we have the capacity? What extra resources? What's the new peak demand? Because you have to almost design your assets and infrastructure for your peak demand, the biggest amount of water you're going to provide. So all of that stuff goes into it.
I'm just wondering how it compares with other areas of the country.
Our population rises the greatest by quite a margin. In fact, I did have another graph, but it's a little bit out of date now because COVID has actually impacted it, strange enough, because of the commuting differences now. And no one has the perfect answer for that commute change. No one has a perfect number at all. But our population growth in the southeast, so when I say southeast, I mean London and the Thames Valley area, exceeded any other region by quite some margin. In fact, there were 2 or 3 water resource zones up north that had negative population.
It's a real concern for water supply. I've got another question on that, but I'll wait and let others have a chance to ask one first. Okay. Thanks very much.
I think Keith was next.
Yes, yes, Andrew, thanks for a very interesting talk. I also had a couple of questions. Years ago, there was talk of a national grid for water supply, and I wondered, it's probably not quite your area, but I wondered if that's still being still thought of as a major way of getting water from areas of the country that have got perhaps more than they need down to areas that are a bit of a shortfall.
So they're not looking at a national grid in that way. What they've done is they're putting together regional plans. So there's the WRC, Water Resources Southeast, there's the Water Resources East, there's the West Country one, there's different regions, and that they're looking at gridding up as part of a regional plan process. So making sure that all the 6 companies in the Southeast covering London and the Southeast are thinking holistically and planned together. There's some gridding up already. There's larger things such as bulk transfers and greater reservoir storage incorporated in that bigger piece of water resource planning. So it's not just gridding up. There are lots of issues with gridding up. Water's heavy and expensive to move around. The other one there too, you got different water qualities in different regions. So water from the Severn area can't just be transferred and put into our area, because you've got a different water quality makeup, and you've also got to consider the different aquatics that might be living there, pathogens and different aquatics that live in there. So those different water quality aspects need to be considered, and you can't do gridding up and bulk transfers without a reservoir. Strangely enough, you need to hold water so you can properly balance it out, treat it, and then put it back into supply. But water transfers, coming back to your original question, is part of the bigger picture piece.
Okay, thanks. I had another question, was about the use of grey water and whether there's, I think you briefly touched on it, that there might be moves into trying to separate out water that's could be reused and then supplied to replace potable water, where you don't actually need to have potable water for the activity.
Water reuse has a role to play. The challenging thing is it can be quite expensive. So for the chunk of water per cubic meter, per million liters, per megaliter of water, it can be quite an expensive way to do it because it's very energy intensive and you need to maintain it differently. The best thing we want to do is get building regulations and planning processes changed to replicate what you'd see in parts of Europe, parts of Australia, parts of US, Canada, to require technologies or incentivize and encourage different technologies so that developers, industry leads this thing. It really probably shouldn't, when it comes down to individual households and so forth, it shouldn't be the bulk water company pushing that thing, but water reuse in general, which covers rainwater capture, grey water, black water, and other things, has huge potential. It's just we don't have a regulatory driver. There's no planning driver or incentive, and it's not a mature market here, but it is elsewhere. Not a perfect situation, but we'll get there one day.
I think I'm interested there in the sort of planning aspect and having some enforcement, and whether the Thames Water would be a consultee on.
We are.
On
so the government, so the water at the moment is Part G of the building regulations. I co-wrote the old one. I want to go back in my DeLorean, hit the flux capacitor, go back in time, and get rid of half of the stuff that's in there because we weren't strong enough at the time to get rid of it. They're consulting now. So building regulations will be replaced or going through a process called Future Home Standard. In that standard will be a roadmap on how water reuse, grey water recycling, rainwater harvesting, other things could be brought into it. First and foremost, you need to strengthen the building regulations, get rid of the stupid liters per person per day metric because it's bonkers for a building and a developer. They don't do that. Get the mandatory label out there in the market. Embed the label in the building regulations so that it's so simple. You remove 12 pages of equations and it goes, we require all new buildings, homes and businesses to put A and B rated products in. That's it. So we'll get there one day. The next phase of that roadmap for Future Home Standard needs to be water reuse. And in parallel with that is the concept of water neutrality, which I love. And that's the idea of that every house or every new development would not add pressure to the grid, would not need new water. So that thing would be water efficient, and that development through planning and various other mechanisms would then help fix leaks and make the surrounding homes and businesses more efficient to offset their use. It's offsetting.
Thanks.
It's offsetting. Yeah.
Hi, Andrew. I just wanted to ask, I've got a couple of questions too. The first one is, there's many sort of things that you can buy for the household that are supposed to be water saving, but they seem to also have negative impacts elsewhere. Like I bought a very supposedly very energy efficient washing machine, but the shortest cycle is like 2.5 hours, and so it uses so much more energy. And I wondered, it's not always that straightforward, and obviously the dual flush toilet is a case in point. Is that it's ironic that this design of toilet that came in as a means to try and save water, it seems to be now the major cause of massive amounts of loss. Is there, do you think that label will be the answer to it being more clear?
Yes, I do. So it's using there's a label already now. It's a trade label. So there's a trade group called the Bathroom Manufacturers Association. It's like their industry representative body. They've got their own label. That will probably be taken independently and evolved into the government funded thing. You can't have a government mandatory label owned by a trade group. That doesn't work. So that needs to happen. And that label is pretty good. We like it a lot. It's just not out there. And even their members aren't even showing it because there's a cost to displaying a label for a manufacturer or retailer. So they don't want cost. So the thing that the label has learned from is where the label is successful internationally. So the real big highlight one is the WELS, the Water Efficient Labelling Scheme, which is Australia and New Zealand, very, very mature, brought in during the early noughties drought. It's evolved over time, mandatory, it's on every product, every website, every shop you go to. I know it very well, but I would just want copy, paste, bring that here. And that there drives change. But what you do is you link minimum standards to it. So apart from just showing the flow rate of a volume, it also has a thing behind it requiring that the device performs well, is built well. It's not rubbish materials. It's not going to fail in 12 months' time. So it has a series of minimum standards that also require that. The label that the government will bring out here will have that involved.
That's great, thank you. My other question is kind of larger, and if I've got this wrong, please put me right. But you said that we actually have less water in the Thames Valley area than most cities in Australia. Yeah,
we get less annual rainfall.
less annual rainfall. That's extraordinary. And I've lived in Australia in sort of, you know, Melbourne, so I know. But to me, why then is there such vast amounts of development happening here when they must have access to that data? I mean, isn't that a massive concern that they're building millions of homes in this area when it is such a sparse, or, you know, a scarce water area?
Yeah, that's our concern too. We're not a statutory consultee, so the water companies in the UK are not statutory consultees on planning.
My goodness,
we're required to. I know, I don't disagree with that, but we are required to provide it. But we are we've got a stronger voice in getting this message across now. It's landing more now. I think the Oxcam is a concern, but it's also an Oxcam potentially as an avenue of testing and delivering best practice, or at least better practice, for a long time. But I guess regardless of what color ties you wear politically, it's like any government in place at the moment is going to face growth targets. So what do you do with growth? You know, tackling population growth is not politically correct or politically wanted by any country around the world. So the next step down is, how do you house people? So, you know, building homes is required, but population is getting bigger. The problem is our population is getting bigger in more concentrated areas, and it just so happens that we are at the higher density area of that population growth.
That's exactly the point. I mean, I think it's because it's such vast amounts over a short space of time. It's not gradual, and you know, if it was sort of divvied up around the place, it might be more sustainable.
It's a twin track approach. We need to reduce demand, reduce leakage. I mean, the leakage on our pipe network is complex and it's too high. We've got to get that down. But even if we got rid of leakage, saved a bunch of water in homes and businesses, in the future, you still need new water into the equation.
Okay, thank you very much.
It's okay.
Jill, I think you've got a question as well.
Yes, sorry, Andrew. You've really been inspirational in talking about the measures that you're trying to encourage for saving water. But I just wanted to ask you about supply, following on really from Andrea's question. You said that in our area, mainly the supply is coming from groundwater, and also that our rainfall is not as great as it is elsewhere in the world. So is it the case that we are actually using up the supply of groundwater, which is not being replenished?
So there's a piece of there's a piece of work going on right now. It's an in-depth study into many of these smaller water resource zones, including the one that feeds. You're in the Chiltern Scarp, so it's the water resource zone that feeds Watlington area. The piece of work is driven by the Water Framework Directive, which is a European directive that we're not, even with Brexit, we're not going to get rid of because it does the right thing. And that's essentially looking at, even the premise of that thing is that even with future growth and increasing demand in water, it's not allowed to negatively impact the quality of the environment around water. So the piece of work that's going on right now in your area is to understand, is the growth in your area, with all the different scenarios, climate change scenarios, everything out there, is it posing a risk to the quality of the environment? They've done phase 1, and I think they're commissioning phase 2, the deep dive work on that area at the moment. So it's different for almost every valley and every small part. So the proper real deep dive piece of research has not finished yet. Won't be too much longer, but they are looking to answer your question in nauseating detail.
Well, I shall wait with bated breath. Thanks very much.
It's quite a dry read. Don't get you excited by it.
Thank you.
Yeah, I had one question actually, which is kind of related to Jill's question. It was just something somebody asked me once, and I really didn't have a clue. But obviously in this country we get sometimes we get too much water with flooding, a lot of flooding. Is there a way we can use the flood water to recharge aquifers?
So yes, you can. There's a couple of different things there. So floodwaters, heavy rain, massive rain after a dry spell is terrible because the ground is so hard and there's very little infiltration, just runs off and it floods everything. The problem is that we don't capture enough. We've got very small reservoirs, and we have to wait naturally for that beautiful natural process of infiltration, filling in rivers and groundwater aquifers. There is a number of systems in the country. We've got a few over in the London area, on the North London area, that we recharge aquifers. So where we've got excessive water, we can pump it back down underground. Crazy process because it stores it for long term. It's fantastic, but you have to treat the water first to potable drinking quality standards before you put it back underground. Then we take it back out when you need it a year or two later. You have to treat it again. So anyway, but that anthropogenic, that human purpose recharge does happen. We do it at Thames. In your area, it doesn't happen like that. So the Chilterns often dry out quicker. The Chiltern Scarp area that we've got close to dries out quite quickly. We monitor all the bore levels and our groundwater levels many times a day in incredible detail. Too much detail for me, actually. But and they keep a very, very good close eye on that, particularly with the increasing emphasis and focus on chalk stream health.
Are there any final questions? Oh, Anne, sorry, go ahead.
Anne, you're on mute.
So sorry, yeah. So I had questions that the last two questioners you've really covered, which has been brilliant. I wanted to ask you about wastewater, because you said you had responsibility for wastewater in some areas. I think we're all aware that we're getting increasing amounts of untreated sewage being put back into rivers, either because there's been floods or storms or something, some incident whereby you can't physically cope with it. But even beyond that, I'm reading more and more that the wastewater, untreated wastewater, is going back into the rivers. I wondered if you could perhaps explain why that's happening and why you're not doing more about it.
But we're doing a lot about it, and that's not just based on political pressure, because I can tell you now that it is the political hot potato at the moment. It's horrific, and if you get one report, you'll end up on the front page of every newspaper, which no one wants, because it's just crucified. You just get crucified. It's horrible. Okay. The simple reason, there's a couple of reasons why it happens. You've got a combined. You're very unique. This is a very, very unique piece of infrastructure globally. It was unique to me when I moved here 17 years ago. Never heard of it before. We've got a combined sewer approach. So rainfall runoff, so rainfall that comes down, hits the ground, runs off into drains, has been designed before our grandfathers in many cases were around, designed to flow into the sewer system. That doesn't happen anywhere else in the world. So you've got huge amounts of volumes of flash flooding, peak rainfall, which gets picked up, other nutrients and sediments and so forth, goes into a system which instantly becomes foul water. That system was designed for a smaller population. That system was designed for less concrete and hard standing area, which contributes to runoff. And that system has not been over time built in capacity, increased in capacity proportional to the population or increased volumes of water flow. And as a safety mechanism, it goes into the treatment plant, gets the capacity. So without causing, is an effort to minimize impact of backflow, the releases into the environment. No one wants that, but we've got to almost either massively increase our capacity of sewers and pipework, or completely redesign the entire system to separate. And so all the new things are separate. All new buildings are not contributing to this anymore. That's been engineered out through a planning process and building regs. So you've still got a massive problem where you've got higher intensity rainfall events coming down. And whether it's climate change induced or not, it doesn't really matter. If you've got more rainfall and more peak flows coming down, that water is going to go into a combined sewer system that was never designed for that capacity.
So what's the timescale for dealing with this?
There's no timescale to fix the entire thing. We've got to fix it one by one treatment plant, one pipe, one pumping station as we go, as fast as we can. We've got a commitment to, I can't remember the deadline now to get rid of it, but there are, I'm going to put my hand up here. There are also instances where we and other water equipment to be at 100% capacity the whole time, and then it hasn't coped with that impact. So we've not had a pumping or a relay valve has not been gone there, or we've not got to the thing in time, or the sensor hasn't been repaired. So then it has opened up as its default position. So there's been human and mechanical error in there as well. And we need to engineer both of those two things out of the equation completely.
It sounds like a confession of underinvestment over a period of time.
You've got to also look at the regulatory environment here. Compared to where else in the world you don't have it. So a regulatory environment here is focused very, very much on keeping customer bills down. That's where the investment comes from. And with shareholder money on pension funds, which underpin many water companies, because water companies are stable environments for pension and hedge funds to go into. And they put their hands in their pockets to increase investment. But there are decades and decades and decades that you've probably looked at and say, okay, we've underinvested based on the population growth. Yes.
So yes, it's really a talk in itself, isn't it? I think.
Oh gosh, you've got many talks on this one.
Yeah. So that's probably. But I know we've run out of time, Andrew. But as we're a climate action group, I just wanted to make one sort of final comment. Really, is just the carbon footprint of water.
Okay.
I think you touched earlier on the point that if we're trying to reduce our carbon footprint, the best thing we can do is have shorter showers, perhaps with it's the hot water usage.
Hot water. So so the carbon footprint of water in general, the anthropogenic water cycle, from the moment we take it from the environment, for the moment that you use it and get rid of it, and we treat it again, which is also energy intensive, but we're using that wastewater and sludge process to generate our own energy now. So we've dramatically reduced our energy consumption within Thames because we're using our own energy that we generate, either through solar, wind, sludge, the whole lot. The thing that you guys can do at home in this one is that the CO2 emissions from household water use, heating water use, is about 4 to 5% of the UK carbon emission inventory. Okay, water companies are less than 1%, I think, of that. So the biggest carbon output of water is heating water in homes and a bit in businesses. So the thing that you can do at home is shorter showers. Don't leave hot water taps running. Don't leave taps running in general. I'm just going to go back to my water resources thing there. Don't leave taps running in general. So saving water on those hot water things will have a beneficial impact to reducing carbon and reducing your own energy bill. I'll throw in there, Jeanette, one last stupid quiz question. Most of the things that you use water in the home are hot water related. You'll have a different proportion of hot to cold because we like our hot water from the basin tap different from the kitchen tap, different from the shower. And we actually know all the kilowatt hour conversion rates for all those different things for Thames and now nationally. So it's a hugely detailed model that we use for that. But the toilet is cold water. Okay, just cold water. However, there's a carbon and energy impact for the toilet on your energy bill. And hands up, anyone, quickly, as we'll finish this thing, hands up, the second and last pub quiz question: how can your toilet contribute to your energy bill? It's a winter thing.
Is there a pump involved somewhere?
Oh gosh, I hope not. No. No.
It cools the house.
Ah, damn. Keith. Mate, if I had a case of wine, I'd send it your way. Or I'd share it with you at least.
Please do.
Maybe I'll share it with you.
Please don't do that.
You are the only person, I've been asking that question for about 10 years after we did that piece of research. You are the only person who has ever got that right.
Oh, it was the winter clue.
Well done, Keith.
Well done.
You've got it.
Andrew, by how much? How much? Sorry, I mean, that would be really small.
It is nearly negligible.
Yes, okay.
but there is an amount. The reason why we did the full research thing in a different company with Thames and other people there, and there was a small gap. There was a gap in the equation, and all the numbers couldn't add up, and that little gap, and we couldn't work out where it was in the full energy balance of the house. And it turns out you've got a cold water system, which is basically a temperature sink, temperature hub difference sitting in your bathroom. You're heating your house, and there's energy transfer. There's heat transfer from the hot, warm room into your cold system, and therefore your cold water in your toilet is using up your energy household by about that much.
Andrew, I'm going to tell the Passive House Institute about that. I guarantee you, it's not part of their calculations.
then we need like commissioning kudos and everything around the Passive House thing, because it's really and the thing that came off that little piece of research and us sitting in a pub after publishing it going, well, what does this mean? And we were wondering whether we should launch the Toilet Tea Cozy company to insulate our systems.
Brilliant, thank you.
This is related, but one of our members who's moved on, I remember she suggested that when you have a hot bath in the winter time, that you leave your water in the tub to cool down, so it's heating the room.
Yeah, can do.
The other side
as long as you get rid of it once it gets cool, then the temperature hitting your house.
Yeah.
Right. I think we probably need to let Andrew go now.
Terry, what I would actually say is, what I would actually say is I would prefer you to use that water instead of letting the plug out. Take the water out and water your garden and your plants with it.
I think we're completely out of time now, Andrew. We could probably go on, but yeah, I think we should thank you very much. That's been a really interesting and entertaining talk. So yeah, thank you so much.
Thank you.
You're welcome. Thanks for the invite.
Thank you very much.
Thank you, Andrew.
I think a few of us are going to stay on